So it turns out that there are more types of roots than square roots. Today we're going to be exploring cubic roots. So cubic roots are very similar to square roots, but instead of dealing with the number 2, they're going to deal with the number 3. So our definition is that the cubic root of a number is going to be defined by the cube root of a cubed is going to equal a. So if you see this, which is the radical symbol with a 3 in it, that means it's a cube root and not a square root. So let's take an example. The cube root of 27 is going to be the cube root of 3 cubed, so that would be the number 3. Now cube roots, they also follow the product rule. That is, the cube root of a times b is still going to equal the cube root of a times the cube root of b. And they're also going to follow the quotient rule, which is the cube root of a divided by b is going to be cube root of a divided by the cube root of b. However, they also follow one more thing. So square roots, you can never have the square root of a number be negative. So like you can't have a number equal the square root of a number be -2 because there's no way for two numbers to multiply together to get a negative. However, if you have a cubic, let's take the square root of -27, well this is going to be -3. So it is possible for us to have negative answers with cubic roots. This is because you can do -3 cubed, which would be -3 times -3 times -3, which would be 9 times -3, which would end up being -27. So because 3 is odd, we can actually have a negative number be our answer. Now let's try doing an example. We want to find the cubic root of 125x to the 7th, which is going to involve using our product property. Well, using our product property, we know this will be the cube root of 125 times the cube root of x to the 7th. So I started by just splitting off the terms with variables with the terms with numbers. Now we know that 125 is equal to 25 times 5. If I divide 125 by 5, I'll get 25 as my answer. And I know that 25 is 5 squared, so this will be 5 cubed. So I have the cube root of 5 cubed times the cubic root of x to the 7th. Okay, let's rewrite that over here. The cube root of 5 cubed times the cubic root of x to the 7th. Well, now I need to figure out this part. So I'm going to write this part here. Now what I'm going to do is I'm going to break apart this x to the 7th to do x to the 6th times x. X to the 6th times x is x to the 7th, so I'm allowed to break it up like that. And the reason I did this is because 6 is divisible by 3, and it is the first number less than 7, which is divisible by 3. So I'm going to use my product rule again to do the cubic root of 5 cubed times the cubic root of x to the 6th times the cubic root of x. So this is going to be a nice number, this is going to be a nice number, and this one is the only one. I've made it so I only have one term which cannot be simplified. So the cubic root of 5 cubed is 5. The cubic root of x to the 6th is x squared. And the cubic root of x is that one we can't simplify any further, so that's just the cubic root of x. Now let's verify that x squared is the cubic root of x to the 6th. So x squared times x squared times x squared should equal x to the 6th if this is really the cubic root. And 2 plus 2 plus 2 is 6. And when I multiply, I add together the exponents, so it looks like that's x to the 6th. So it worked out, and this is our final answer. Now let's try it with the quotient rule. We're going to do the cubic root of y divided by 64. Well, using the quotient property, this becomes the cubic root of y divided by the cubic root of 64. Now this can't be simplified anymore, so we're going to keep that as it is. But we know that 64, when we divide it by 4, is going to be 16 times 4. And we know that 16 is really just 4 squared. This is 4 cubed. So the cubic root of 64 is just 4, and that is our final answer.